Okay, abstract class and Java interface. As I said, this is probably the most important topic today. Okay, so abstract class and Java interface. So we are going to learn the concept of abstract class and abstract method, and we'll learn the concept of interface as well. And we are going to see why interface is important. In fact, this is pretty important in Java. It actually provides the power of Java. I will talk about the concept of interface as a type. We actually touched upon the concept of type in our previous presentation of Java inheritance, but we haven't really looked into why that is actually a very significant aspect of Java programming languages. So we can actually look into that. We'll compare interface versus class. When you design your class, you have a choice of creating as a genuine, just vanilla class, or you can you can actually come up with an interface and its implementation. So between the two choices, which one to use and why. Okay, we'll see how we can define an interface and how to implement an interface, and we'll see how you can implement multiple interfaces for your class, and also talk about inheritance among interfaces. Interfaces themselves could have inheritance relationships, so we'll see how that works out. And last topic is rewriting an interface. Okay, so we have a pretty decent set of topics we are going to cover. What is an abstract method and abstract class? The abstract method is a method that does not have implementation code, meaning it doesn't have code block. Okay, because it doesn't have a code block, it doesn't have this curly brace. Okay, so example of abstract method is like this: public abstract void some abstract method, and parenthesis, you could have some arguments, and there is no curly brace because abstract method doesn't have any body, it doesn't have any implementation. So in order to specify the method as an abstract method, you have to use abstract keyword. Okay, this is the case in abstract class. So abstract class is a class that contains one or more abstract methods. Okay, the way that you specify that a class is abstract class is that, again, you are going to use the abstract keyword at the class definition. So you specify your class to be abstract class. However, if you do not include any abstract method, that's a compile error. So abstract class has to have at least one abstract method. Okay, so let me see if we have, so this is the way that you specify the living thing class is an abstract class. And it should have at least one abstract method. At the end, we have an abstract method. And you could also have concrete methods, but it should have at least one abstract method. So you can see this abstract method does not have any code block. These concrete methods have code blocks. So we have the curly brace. Inside you have a set of Java statement. Same thing for it, concrete method. But walk is an abstract method, and it doesn't have any code block. Okay, so let's get back to previous slide. So abstract class is a class that has at least one abstract method. And again, if you don't have an abstract method but specify the class to be abstract class, that's a compile error. Abstract class cannot be instantiated, meaning you cannot create an object instance from it. Okay, so if you try to create an object instance by using new keyword, and if my abstract class is an abstract class, this is a compile error. Okay, so in order to create an object instance, there has to be what is called the concrete class that provides the implementations of all abstract methods. So another class has to be provided or created to provide implementation of all abstract methods. So this concrete class uses extends keyword to extend abstract method. Okay, and this concrete class has to implement all abstract methods of abstract class. Okay, it cannot pick and choose to implement among the abstract method. It has to implement all abstract methods defined in an abstract class. Otherwise, it's a compile error. Okay. Okay, so this is an example that we talked about here. So living thing class is an abstract class because we say so. So we say so by using abstract keyword. And it has to have a single or more, one or more abstract method. In this case, it has a walk abstract method. So there has to be some concrete class that implements this walk abstract method. So let's say an example of a concrete class, in this case called a human. Human class extends living thing class, and living thing happen to be an abstract class, which means this human class has to provide implementation of abstract method defined in living thing abstract method. And there is only one method that it needs to implement, which is a walk. So in this case, walk is implemented and it provides some implementation code. Make sense? Any question so far? Okay. So when do you want to use abstract methods and abstract class instead of just vanilla concrete class? So abstract methods are usually declared with when two or more subclasses are expected to fulfill similar role in different ways through different implementations. This is in fact polymorphism. Yeah, so again, we're going to talk about the polymorphism in a bit more detail, well actually a lot more detail in our polymorphic presentation. That's our next presentation. Okay, so just for now, just consider that abstract class and abstract method could be used to provide a polymorphic behavior. So in our previous presentation, we talked a little bit on polymorphic behavior by using overloading methods of the superclass, right? Usage of abstract method and abstract class is another way of providing polymorphic behavior. Okay. All right. So for now, don't worry about this bullet, okay? Because we're going to talk about it in detail later on. Okay. So you want to use the abstract methods to define broad type of behaviors at the top of object-oriented programming class hierarchy, and use subclasses to provide implementation details of abstract class. Okay. Again, this is related to this polymorphic behavior. Okay, so we are going to actually use example to explain these points in detail. So if you don't understand what I'm talking about here, don't worry about it. Okay, so let's do the exercise 1. Exercise 1 is okay, so we are going to create a new project called the My Abstract Class project, and we are going to create living thing abstract class. Okay, so you're going to say public abstract class living thing, and it has a few concrete method. It has a constructor method, and it has a 2 concrete method, and it has the instance field. Okay, and then it has a single the abstract method called the walk. Yeah, so this is pretty much the same thing we have seen in the slide. Okay, and then you write human concrete class, which extends living thing abstract method. So we have to provide this walk implementation. So if you don't provide it, then it's a compile error. So you might, you might just comment this out and experience compile error first. Okay, and then monkey class also extends living thing, and monkey class has its own implementation of walk. Now you can see there is a walk method as an abstract method, but subclass, and it's not subclass, but the concrete classes like a human and monkey, they provide different implementation, right? Because human and monkey, they actually walk in different way, right? So they need to be provided in different implementation code. Okay, and then we write the main the Java. So we created human object, and obviously we can call walk method of the human. So this is going to actually use human's version of the walk method. Okay. Now let's take a look at this one. So we assign human one to living thing type. So again, we are actually touching upon the concept of type, right? So human must be the type of living thing, because human class is extending living thing class, right? So we should be able to use this living thing as a reference type. So now when we call walk method of this living thing type, it will actually use human version of it, because this living thing is in fact pointing to human object. What about the monkey? So we actually created a monkey object and then assigned to a living thing type. And when we call walk method of this living thing type, a living thing 2 reference variable, the walk method of the monkey implementation will be called. Okay, so when you run this 2, you should actually see human is walking. Yeah, human works, and the monkey walks. Monkey works. Okay, and and we also display the name. Okay, so again, we actually call the get name. Get name is where from? That's actually from the that's actually from the living thing abstract method, right? Okay, so the get name is actually from the living thing parent class, so to speak. Okay, so human and monkey, they all should be able to call get name method, right? Okay, now you want to, so in this case we are just comparing human 1 variable, reference variable, and a living thing 1 is referencing variable of this guy, whether they are pointing to the same object, and should actually pointing to the same object. It should return true. Okay, now this thing, so this one, when you try to create an object instance from abstract class, that's a compile error. Okay, all right. For your own exercise, define another abstract method in the living thing Java. So that abstract method is going to be called the dance. Okay, and you can pass some dancing style, tango or whatever. Okay, and then you're going to implement concrete method in human and monkey class of this dance abstract method, and modify main.java to invoke dance method through object instances of human 1 and living thing 1. Okay, and the dancing styles you can use is tango, cha-cha-cha, or whatever you want. Okay, all right, that's 1.1. Let me see whether that, so the next one is 1.2. Now the online shopping application that we have created, we have worked with in the in Java inheritance. In Java inheritance, we have built online application using overloaded method, right? Now we are going to build the same application using abstract class and abstract method. Okay, so now here you are going to create a product as an abstract class. So so now the compute sale price is an abstract method, and we don't have to provide an implementation of it because it's an abstract method. In our inheritance example, we have to actually provide some implementation because we were overloading the product was in fact the non-abstract class. We have to provide implementation in our example of Java inheritance. But now we make product class as an abstract class, and then we make compute sale price as an abstract method. Okay, and then the electronics.java, it also actually make it as an abstract. Okay, because we do not provide implementation. So even if electronics extending product, because it doesn't provide implementation yet, you still have to specify abstract. Otherwise, it's a compile error. Remember, any class that extends a product has to provide an implementation, right? If it doesn't provide an implementation, then you can just specify it is still an abstract class. Okay, and then we have MP3 player Java class. That's the one that actually provides implementation. So here in this implementation, we provide MP3 player specific discount rate. Okay, and here you can see it extends electronics. And the same thing for TV, and TV is concrete class that provides implementation of compute sale price. And the same thing with the book. And the main, it works pretty much the same. Okay, the only difference here is that you can see so it's pretty much the same code. Product is basically abstract class, but we can certainly use this product type as which is the abstract class as reference type. Okay, so main, as far as the main is concerned, is pretty much the same as the one we have seen in example code, online example code in Java inheritance. Okay, let's see. And okay, so that is an exercise. Right now is the 5 minutes to 12:30. So let's have a 20 minutes lunch time, and I'm going to give you guys about 20-25 minutes. So we'll be back in 40 minutes. So we'll be back 5 after 1 o'clock. Okay. Okay, so we talked about abstract class and abstract method. Now let's move on to interface. As you're going to see in the following slide, abstract method, abstract class, and interface, they are somewhat similar. So what is an interface? In interface, all methods are abstract methods. So in abstract class, a subset of all methods are abstract methods, right? But in interface, every single method is an abstract method. Okay, so basically it is a set of methods without body, meaning without implementation of the methods, without the curly braces. Because every method is an abstract method, there is no need to specify abstract modifier for the methods. Even though I think it's still accepted, in interface you can still use abstract modifier for each of those methods, but you don't have to, because every single method is an abstract method in interface. Okay, now because interface does not have any implementation, there has to be some concrete class that implement that interface, just like abstract methods of abstract class need to be implemented by the concrete class. Okay, so just like abstract methods of abstract class, all methods in an interface need to be implemented by concrete class. Okay, so how are you going to define an interface? You define an interface using interface modifier. Okay, so you're going to see that example later on. So what is interface for? It defines a public way of specifying the behavior of the classes. So it is used as a contract between client and provider of some task. So the client is a user of the interface, and provider is the implementation of that interface. So interface as a set of methods clearly specifies the contract between the client and provider. Okay, is that a question? Is there a question on this slide? Yeah, we're gonna actually talk about these things in a bit more detail moving forward. Any questions on this slide? Okay. All right, so this is the way that you are going to declare or define an interface. You're going to use interface, the keyword, and then name of the interface. So in this case, we are defining relation interface with a set of methods. So here we have is greater, is less, is equal. We have 3 methods in this interface. Okay, so these are all abstract methods because they do not have any implementation body. Make sense? Okay. This is another example. So here we have interface called operate car. Okay. You can actually have a constant declaration in interface, but it's pretty rarely used. Okay, so not that important. So what's important is the set of methods that you define in your interface. So in this case, we have defined turn, change lanes, signal turn, get data front, get data rear. These are all methods without any implementation, without any body. Okay, so now we are getting to why interface. So here we are going to in fact talk about why abstract method of an abstract class as well. So you can see the similarity between abstract class and interface. Interface is just the extreme version of abstract, so to speak, because in interface all methods are abstract methods. Okay, so these are critical concepts you need to understand. So we are getting into why the interface is in fact useful thing to use. There are several reasons. Reason number one. So it provides more powerful encapsulation. So in order to reveal object programming interface, meaning the functionality of the class, without revealing its implementation, the only thing it reveals is basically the set of methods. Okay? So there is no implementation involved. Okay. So when we talk about the class, we talk about implementation, encapsulation as well, but it's actually lower level of encapsulation than interface, because a class, could be actually analyzed by using reflection, and people can actually find out the method implementation as well, right? Okay. So in the case of interface, there is no implementation involved. It's just a set of methods. Okay. So it provides more powerful encapsulation. And implementation can change without affecting the caller of the interface. The caller only cares about interface, and so that implementation can change as long as the contract of contract is stay the same. So when you define an interface, basically it's a contract between the user of the interface and implementer of that interface. As long as that interface stays the same, implementer can actually change the implementation detail. Okay. Now another important aspect is that caller, meaning user of the interface, does not need the implementation class at compile time. Only interface is needed. Okay. So in many organizations, different groups are working on the different pieces of the project at the same time, but they need to interact, right? So basically what they do is they define a set of interfaces and they can compile their code. Okay. And they might actually use some kind of mock object that provides the implementation of those interfaces while the real implementation is being developed at the same time. So different groups can work in parallel with one interface, with only interfaces defined. And during runtime, object instance gets created from implementation class, and then it will be dynamically associated with interface type. Okay. So again, as I said, a group who has interface, can just use interface with some kind of mock object. Okay. And then when they synchronize with other group, they might actually use a real implementation class for that interface. So it's important that interface is just there is no need to have real implementation for a group to proceed. So it allows multiple groups, different groups, to work in parallel. Question on this slide? Any questions? Yeah, feel free to ask any questions you have. I mean, we are actually looking into very important concepts here. Okay, let's move on to the next reason why interface is important. you can have unrelated classes implement similar methods behavior. So, let's say we have a class called line and a class called myInteger, and they are not really related through inheritance, meaning myInteger is not a parent class of line, and line is not related to myInteger. Okay. However, if you want to provide some kind of common behavior on these two non-related classes, okay, you can ask each of these classes to implement the same interface. Okay, so basically I want both of these unrelated classes to have some kind of comparison method, like a check is greater, check is less, and check is equal. Okay, so basically we can define interface called the comparison with these three methods, and then we are going to have line and myManager classes to implement it. So basically by using an interface, we can impose a common behavior to non-related classes. Okay. All right, question from Joel. Would an abstract class be different than this? Probably not. Okay, but there is actually one constraint. A class can only have one single parent, including abstract class. Okay, so suppose the line class already has a parent class, and myInteger already has a parent class. Then you cannot use abstract class, right? In that case, you have to use interfaces. Does that make sense? Yeah. Okay. Reason number 3. You can model multiple inheritance. So if you want to impose multiple behaviors to your class, okay, you can use a multiple interfaces, meaning each of those interfaces will define a set of behavior, and you can make your class to implement all those 3 or 4 interfaces. Okay. In Java, you cannot have more than a single parent. In other words, there is no multi-inheritance supported in Java for a good reason. However, if you need to have multiple behaviors, okay, then you can use, in fact, the multiple interfaces. Okay, so each set is defined as an interface, and a class can implement multiple interfaces while it can extend only one class. Okay. Question from Roger. How can a class implement multiple interfaces but one class is only extended? Yeah, I'll give you an example in a few minutes. Okay, so basically a class can have a single parent class, meaning my class can extend one parent class, but they can implement multiple interfaces. Okay. Question from Joel. What would happen if there are conflicting behaviors in multiple interfaces? Would that be compile time or runtime error? So you have to give me more information. What do you mean by conflicting behaviors? So let me just forward this question from Joel so that everybody got the concept. The question is, what would happen if there are conflicting behaviors? So I think what you're saying is, so give me a bit more context in terms of what you mean by conflicting behaviors in multiple interfaces. Basically, they should not. Basically, we're talking about just the interfaces are basically the set of methods, right? So there is no implementation, so there should not be any conflict. Okay. Maybe what you're asking is if multiple methods have the same method. Is that what you're saying? Yeah. Okay. That's an excellent question. All right, let's actually try that in our hands-on lab. Yeah, I don't know the answer, but something we can try in our hands-on lab really quickly. Okay. Good question. Yeah, so I want everybody to actually try that. So remember this question. Question is, when you have a multiple interfaces, and if those multiple interfaces has the same method, what needs to be done? Okay. All right. Okay, now let's compare interface versus abstract class. So the differences are all methods of an interface are abstract method, while in abstract class only a subset are abstract methods. Okay, and abstract methods in abstract class must have an abstract modifier, while abstract methods in interface do not have to have abstract modifier, even though I think it still allows it. Okay. An interface can only define constants, while abstract class can have fields. Okay, so this is another difference. So interface cannot have fields. Okay, now moving forward. Interface as a type. So this is a critical concept. We touched upon the concept of type a bit, right, in our previous presentation and this presentation. Now we are actually talking about interface as a type, and this is very, very important concept. Okay, so interface as a type. The slide number 1, as I said, I want to emphasize this aspect is very important. When you define a new interface, you are defining a new type. Okay, just like when you are creating a class, you are defining a new type, right? Okay, so because an interface is a genuine type, you can use an interface anywhere. You can use a class as a type. Okay, so in fact, usage of interface as a reference type as opposed to class is strongly recommended. Okay, because it provides loosely coupledness between the user and implementer of that interface. Okay, so let me give you an example. So this is an example that we have seen before. We basically create a person object, and then we are using person class itself as a reference type. Okay, now any place we are using person, assuming person is in fact the implementation of person interface, we can use person interface in any place person class is used. So this example, interface is used as a reference type. Same thing here. In here we are creating person object and assigned to person interface type. Okay, so usage of interface as a reference type is a recommended practice. Okay, and I'll talk about it why that is the case. Okay, so I want you to spend a minute or two, actually, maybe 30 seconds a minute, to digest the things that I said on this slide, and let me know if you have any question. Okay, cool. So let's move on. Interface as a type. So this is the case that we are using interface as reference type, and same thing for class. We are using class as a reference type. Okay, you can also use argument type. Okay, in fact, when we say reference type, we are actually including argument type as part of it. But just to be more clear, I'm actually giving you another example where there is a method that is receiving person class as argument type. Instead, you can use person interface as argument type. Okay, again, this is a recommended practice. Usage of interface is recommended practice. Okay, question from Robert. Does interface have access to the methods of the classes it's connected to? Excellent question. So let me just forward the question. So does the interface have access to the methods of the classes it is connected to? So that's an excellent question. What do you think? Maybe this example and this example. Anybody? So Joe was actually making a comment. By connected, I mean, I assume he means implemented by. I would say no. Okay, so forwarding. Well, I guess the connected to is basically implemented by. Yes. Okay. So Joel said no. Anybody else? It declared them, yes. So Dimitri say yes. Well, it has to have it, right? You know, basically, once you, if you take a look at this slide, right, we have a P12, right? So P12 should be able to actually access all the methods of person interface, right? So at this point, when you do this, underneath this person object is, you know, the assigned to this person interface type. So this type is pointing to the object. So this P12 should be able to invoke all the methods of person interface, which is actually calling the actual person object person implementation. Does that make sense? Yeah. Okay. Cool. So this is in fact working exactly the same in our inheritance. Remember, in our inheritance, we have a child object to be assigned to parent. Child object is assigned to the type of parent class type, right? And from the parent class type, we were able to actually call all the methods, but it's actually invoking the actual objects implementation of the classes, right? Okay, so same deal. So P12. So this is an example, of course, in the reference type as a variable. So same thing over here. So when we receive person interface object, we receive it as a P. Then we should be able to call P's method, meaning all the methods of person interface should be able to be invoked. By the way, when this A method is being invoked, obviously it has to pass the concrete object instance, which is the type of person interface. Does that make sense? Okay, good questions, guys. Any other questions? Okay, moving forward. Okay, interface versus class. So if you compare interface against the class, interface and class both define methods. So that these are common aspects of interface and class. And as we talked about, interfaces and classes are both types. Okay, which means interface can be used in places where class can be used. Okay, so as I said, usage of interface as reference type is recommended. So rather than doing this, okay, usage of interface is recommended practice. So this is recommended practice. This is not, meaning you do not want to use a class like this as a reference type. The reason is this. There are two reasons. Well, actually, there are several other reasons, but these are probably important. Person class implementation has to be present during compile time. So this is going to prevent two different groups to work in parallel. If a person class needs to be implemented by group A, and then the code is, this code is being written by group B, group B needs group A to provide the person implementation. Right? Now, in this case, by using interface, group A and group B, the only thing they need to define and agree upon is person interface. There is no need of person implement, at least the real implementation is not needed by group B. Well, group A, one of those. Okay. So that's one big reason. And also, your code is tightly coupled to person implementation. So if person implementation, in fact, is changing, your code might, in fact, be changed. Okay? But by using person interface, the person implementation can change without affecting my code. So basically, by using interface, you are basically loosely coupled rather than tightly coupled. And loosely coupled is always a good thing because it let different groups actually to proceed without affecting each other. Does that make sense? Question? Okay, so let's move forward. Okay, differences. The methods of an interface are all abstract methods, meaning they do not have any implementation code. Okay, and you cannot create an object instance from an interface. So you have to create a concrete class that implements that interface in order to create an object instance. So just like an abstract class, you cannot create an object instance from an interface. And that makes sense, right? Because implementation is not there. Okay. Okay, now, so, basically I want you to remember interface is a type. So these two slides are very important. Okay? All right. Question from Dimitri. Why Java has abstract class option if interface much more powerful and do the same thing? Yeah, good question. So we're going to actually talk about that in a few minutes, okay? All right, so let's, we just talked about this. Yeah, so how you define an interface? As I said, you're going to use interface keyword, right? Public interface, and then you specify the name of the interface, and then you provide a set of methods. So this is an example of defining relation interface. Okay, how do you implement an interface? Basically, you are going to use implements keyword. So in this case, line class implements relation interface. So line class has his own methods, but it has to implement all abstract methods of relation interface. Okay. Yeah, so it basically it should implement is greater, is less, and is equal. Those methods need to be implemented. Okay. Okay. So implementing an interface, when a class try to implement an interface, so the class has to provide implementations of all methods, otherwise a compile error. Okay. Yeah, so this is not, so you can say line is not abstract and does not override abstract method, blah blah, in relation. It's basically indicating something is wrong, and the not all abstract methods have been implemented. Okay, so which one to use? So you have an option of, suppose if you are building person class, okay, you have an option of creating person class only, meaning you just have person implementation class, or you have an option of person interface and person implementation. Okay, so which one to use? Okay, so we're going to actually assume before we talk about this, if person class is used only within a particular application, meaning you are the only one who's using a person class, then it probably doesn't make that much sense, or it's not probably needed to separate it out, person interface and person input, because your code, or you are the only person who access it. Okay, and the possibility of the refactoring might be actually pretty small. Okay, and it doesn't really affect them much. But suppose the logic of person is going to be used by some another person, meaning some another developer or some another group. Okay, so that's the time that we are going to actually look into whether we want to just use a class or interface and implement the choice. So so let's say we have two choices: provide person class or provide person interface and person import class. Okay, assuming the logic of this person class need to be used by other people, other developers. Okay, so in general, you want to use the option 2, meaning provide interface and implementation. Okay, So as I talked about, as I said before, other people do not need only interfaces at compile time, and you as a provider can actually change implementation class. Okay, this person input class, the logic of person input class change without affecting these other people. Okay. Choose option number 1 if the class will be used rarely and do not change. If you have some level of guarantee that the class will not be changed, then maybe usage of just person class might be okay. Okay. All right, moving forward. Okay, so exercise 2 is interface as a type. So since this is important aspect of it, I'm gonna let's actually do the exercises. Yeah, so here we created person interface. So person interface has compute total wealth and then person's name. Then we have person concrete implementation class implements person interface. Okay, so it should actually provide these two concrete implementation. Okay, so basically it provides the implementation logic here. We are just displaying total wealth is just add a cash saving and retirement fund and just return the addition of it. Okay, and then get name is just returning first name and last name, not a big deal. Okay, and then we write the main class. Okay, so main class we create a person object. Okay, and then you can assign. So instead of actually assigning person 1 to person the type like this, we are going to be able to use person interface like this. Okay, and you can see we should be able to use this person interface 1 object. So we could use all the method of the person, so we are just using this person interface 1 here, right? Okay, so we should be able to use all the methods that are defined in person interface, and internally it's going to actually use the person implementation class. Okay, all right, so this one is so we just compare person 1 and person interface 1, even though the types is different. So person 1 in this case is type of person interface 1 is a type of person interface. They are pointing to the same object. So if you compare with this equal operator, so remember yesterday when equal operators are used, when it is used with the object, it's checking whether those two reference variables are pointing to a same memory object, same object instance in memory, right? So this one should return true, right? Okay, and we can directly create the person object and assign to person interface like this. Okay, so again, it's pretty much the same deal, and you should be able to run and build and run the application, and should work fine. Okay, to that too, this we are going to actually use relational interface. Okay, so we are going to define an interface called the relation interface, and that is 3 different methods, abstract method, and then we are going to have a concrete implementation class, in this case line. So line implement relation interface, and it has its own set of methods and constructors, but it has to provide the implementation of those 3 methods defined in interface. Okay, and the logic of these things is probably not that much important. Okay, so it's just the important that these implementation needs to be present in concrete class, and then modify the so basically when we create line object, we can now assign to relation interface type. Okay, so in our previous example, we have a person interface, so that's actually the type. Now I can assign the line object into relation interface type. So relation interface is not directly related to like line, but because the line is implementing relation interface, we should be able to use this relation interface as a reference type. Now, what it means is that with the line 3, we should be able to invoke only the methods defined in this relational interface. Line 3 cannot invoke other methods in line class. Okay, so when it's trying to call like a getLength method, it is a compile error, because line 3 is basically relation interface type, and it should be able to call the methods defined in relational interface and in relational interface only. Does that make sense? Okay, yeah. All right, so that is so for your exercise, on comment, yeah. So basically on comment, and then see the compile error. Okay. Okay, so let me see what exercise I want you guys to do. Okay, so let's move on. So I'm gonna actually let you guys do this exercise, okay, just to follow the logic and understand what's going on. Okay. Question from Dasu. We still need concrete class line. Yeah, of course. You need a concrete implementation. Yeah, question from Dasu. Yeah, so I'm gonna forward. So the let's see an example. So the question is, let's have an example where we can implement, we can compile some code using just interface. Okay, so let's actually do that. Interface. So this is okay. So this is the my person interface project. Okay, so let's use my person interface. Or let's use the relations, because that's what you're asking, right? So so in the main class, okay, so the question is, how can a code can be compiled without the actual implementation? Okay, so in our case, in the main code, so let me just remove this guy. Okay, I'm gonna just change the name to let's see, line XXX or something like that. Okay. Actually, this is not good. Yeah, I actually refactor, so that's not what I want. Let me just change it back the line, and then actually I'm gonna just remove this guy. Okay, so as soon as I remove line concrete class, I got the compile error, right? So this is the reason why you should not use the concrete class in your code. Okay, so maybe I should use line it's like a relation interface. So instead of using this guy, I should use whatever interface, relation interface. And instead, in this case, I'm actually using new keyword, but typical production environment, you are going to in fact use some kind of factory class, like a create the line of create an object, something like that. Okay, so basically you are not going to actually use this concrete class in your code. Instead, you are going to use some the all interface like this. Okay, so as long as you're just using interface, let's see, I'm gonna just fake it. Yeah, so I'm gonna just have create object. So let me actually create a factory class. So I'm gonna just create the factory class. Name is my factory, and this factory class will have a method called relation interface x, and it will probably, this code might actually use the line. Yeah, so this is the one that actually might actually use a line. Yeah, so I need to actually line class again. So yeah, so this is the probably factory. I'm gonna just explain it. Okay, this is probably the factory class or some kind of logic that might actually create a concrete object. Okay, like in this case a line, but your code, in this case a main, is your business logic code. So as long as main, your business logic code does not actually use a line, the concrete class, it basically use only interfaces, it should actually compile. Okay, so this code should be able to compile without the without actually having line implementation. Okay, I should actually in fact have a better example. So let me actually think about the that example, because I think that's actually the probably a good thing to have. But do you actually get the sense of what I'm talking about here? So your business logic, as long as it's just using interface, it should compile. Okay. Let me come up with some example. so this is probably kind of convoluted. Yeah, so I came up with an example where I have my business logic, in this case captured as a main, and basically I use my factory class, so this could be some logic that some logic in your application will provide to create the line object. If you go to my factory, you just create the line object, and I just received the relational interface here. So, I mean, this is an example. I mean, I can actually use the whatever methods in relational interface to perform things, right? So this code is, in fact, the compiled without accessing line class. Okay, I need a line class because I need my factory is being used in this package, but I can certainly have the this my factory to be in another package that actually use a line, and the main does not need to anything about the line class. Okay, so this is being compiled without a problem. That's actually a little bit convoluted example, but just to show the point. Okay, so Joel, you want this code? Yeah, so yeah, I'll actually add an exercise on this, okay, to the lab document. Yeah, this is probably not, yeah, because I want to actually use the relational interface, but it requires the line object. So this is probably not the best example. I might actually come up with something else. Yeah, so it is a factory pattern, yep. Next. Now, let's talk about how you can implement multiple interfaces. So, as I talked about, a concrete class can only extend one super, meaning one parent class, through inheritance relationship. However, it can implement multiple interfaces. As I said, Java programming language does not permit multiple inheritance. That's the reason it can have only a single parent. So these multiple interfaces provide an alternative, meaning you can impose multiple behaviors through the multiple interfaces. So if you implement multiple interfaces, then you have to implement all methods of those interfaces. Okay, otherwise a compile error. So let's say an example. So here we have a class called the computer science student, and it already extends student class. So there is no way to have a second parent. Okay. However, you could implement multiple interfaces. So you could implement person interface, another interface, and third interface. And all methods of these three interfaces need to be implemented. Okay, so basically you can impose behavior of these three interfaces to your concrete class. Okay, so that is exercise 3. Let me actually shows you on this one, and I'm going to actually talk about the next topic as well. So here we have interface. Yeah, so basically we have another interface example. And so basically this person class implements person interface as well as another interface example, so which means it should actually implement all methods. So we have implemented this person interface methods, and we also implemented another interface method. Okay, and in the main code we can display the measure intelligence. So basically that is the measure intelligence method. We can actually call that method as well. Okay. Now let's take a look at this guy. When you're trying to call measure intelligence method on person interface 1, that is a compile error. Because when you're using person interface 1 type, so that's a person interface type, you should be able to call only the methods defined in person interface. So when you're trying to call another method, okay, when you try to call a method not in the person interface, that's a compile error. Okay. However, you can assign this person object to another interface example type. This is perfectly fine. So we should be able to use all this interface as a type. Okay. Now we should be able to call method in another interface example. So now we should be able to call what is the method we should be able to call? So measure intelligence. Now we should be able to call so I should have another example right here. So in this case I should be able to call measure intelligence on this guy. Okay. Let's see. So so there's something I want you to actually try it right here. So see right here. Okay, so see whether you can actually call the measure intelligence method on this interface. Okay, all right. That is and also for your own exercise, add third interface with the following method. So the method that you want to have in that third interface is compute first name length. Okay, and then make the person class to implement this third interface. Okay, then modify the main Java to display the information accordingly. Okay, all right. So let me move on to the next topic, and I'm gonna let you work on both. Okay, inheritance among interfaces. So we know the classes have inheritance relationship, meaning there could be a parent class and child class. Okay, and between a class and interface needs to be implemented by a class. Okay, now between interfaces you could have inheritance relationship, which means you could have, in this case, person interface, and then you could have student interface, which extends person interface. So in a sense, student interface is a child interface of a person interface. So between interfaces you could have child and parent relationship. Okay, so if you are implementing student interface, you have to implement all methods defined in this interface hierarchy. So you need to implement not only do extra something method, but also do something method as well. Is that clear? Okay, so let's take a look at the exercise 4. So in exercise 4 we have the student interface, which extends person interface. So we have a method called the find school. Okay, and so when we have a student class which implements this student interface, you have to provide implementation not only for the person interface as well as student interface. Okay, and so here from the student interface you should be able to call all the methods defined in the class the interface hierarchy. So this get name is from the person interface, right? Compute total width, this is from a person interface, and this is perfectly fine because student interface is in fact a person interface type as well. It's a child interface, and also you should be able to call method in student interface. Okay, all right. Okay, so I'm gonna let you guys do exercise 3 and 4. I'll give you about 15 minutes. Hopefully that should be enough time. Next topic is rewriting interfaces. So let's talk about rewriting existing interface and what kind of problem that might cause. So let's say we have an interface, call it interface called the do it. So it has two methods: something, do something, and do something else. Okay. Later on, you want to add another method, third method, to the interface. So interface will look like something like we have added did it work, Boolean did it work method. We have added it. Okay. The problem of this approach is that all existing classes that implemented the old do it will break now because they didn't implement all the methods of the new do it anymore. Does this make sense? So basically just adding a new interface method is going to actually break all the existing code, and obviously that's not really desirable, right? So what is an option? The solution is you are going to create, in fact, child interface from existing interface. So you might, in fact, create another child interface called do it plus, which extends do it interface. So now this do it plus interface will add did it work method like this. So if you do this, the old code that uses the old do it interface still should work. However, new code can take advantage of do it plus interface. Does this make sense? So this is a scheme that you want to use. Okay, so exercise 5. Let's take a look at the exercise 5. It's basically, rewriting things. So we have Persian interface, and if you try to add new method, then it's going to cause a problem. Okay. So you're going to actually see the compiler problem right away. So, as soon as you add something to Persian interface, another method, you will see Persian class that implemented the old interface, it will cause a compiler problem because it didn't implement all the methods. So that's not right. So, what we want to do is we want to create Persian interface, another interface, which is wait a minute. Oh, yeah, one option is basically you can create another interface like a Persian interface, another that actually has a new method. And then you can have the Persian another is not only implementing old interface, but also the implementing new interface. Okay, so this is one option. Another option is the implementing so another interface is to create the new interface that extends the old interface. Okay, so Persian another 2 is extending Persian, and then it's extending implements Persian interface another. Okay. Oh, so yeah, we're actually looking at the various options. So in this case, we can create a Persian that actually uses only this interface. Okay. And yeah, so it looks like this does not really match the description I have in my the presentation, but yeah, either scheme should work fine. So the two scheme is basically the Persian class should actually implement the one interface, and the new one should actually implement these two interfaces. Or another option is creating creating interface that extends Persian interface and add another method. Okay, so those are two options you have. Okay, all right, so that is okay. So let me actually finish up the presentation, and yeah, I should actually update that documentation to be more aligned with the presentation. Okay, so I think one of the questions that was asked was, between abstract class versus interface, which one do you want to use? Okay. So when to use abstract class over interface? So the the situation you want to use the abstract class instead of interface is that when you happen to have some concrete methods that you want to impose for all subclasses, okay, that's the time you want to use the abstract class, because abstract class, the difference between abstract class from the interface is that abstract class can have concrete methods, right? So you could have these concrete methods that could be actually inherited by all subclasses. So if you are reasonably sure that all subclasses should have this common set of implementations, then you want to use the abstract class. Okay? But the thing is that if you know that they are all sharing the same set of implementation, but if you're using interface, then all those subclasses have to actually duplicate the same code. So that's the time that you want to use the abstract class over interface. Okay. If that's not the case, meaning if you know all implementation classes will have different implementations for all the abstract methods, then you want to use the interface. Okay. And one more constraint is that if you have already extended parent class, if the class is already have a parent class, then you don't have any other option except using interface. Okay, because you cannot have the multiple parent classes. Does that make sense? Okay, so let me actually see one question from Dimitri, and then we'll do exercise 5. How to maintain interface version? Yeah, so I think interface version, you might in fact have a version number as part of your interface name. So that's actually something you can do. There is no built-in version control system in the language, so you have to actually deal with the version control of yourself. Okay, so maybe the naming could be one thing, and also you can have a constant value in each interface. So constant value could actually provide some version number as well. Okay, yeah. Okay, so I'm gonna let you guys do exercise 5, the last exercise. I'll give you just 5 minutes, and then we'll actually move on.